everyone. I'm here with Opher from an amazing company called EVR Motors. And Opher, please tell me about yourself a little bit. Tell me about the company. I'm very excited.
Okay, I'll start with myself and then go on to the company. I've been CEO of EVR Motors for about 2.5 years.
Okay, nice.
Previous to that, I spent 8 amazing years as the general manager of the space division at Israel Aerospace Industries.
Wow,
So
that's
I was in
interesting.
charge of the few hundred people that design and build Israel spy satellites and communication
Wow,
satellites. I led the Bereshit lunar lander mission, which reached the moon way too fast 2.5 years ago.
wow.
Way too fast is the code word for crash landed on the moon.
Yeah,
But it was very exciting.
that is very
Uh,
exciting.
Previous to that, I spent several years in defense industries and over 20 years in the Navy, where I commanded a variety of different warships, from small missile boats to Corvette and Corvette Squadron.
Wow.
And I was in charge of the operational requirement for the Navy, which is the body that decides what type of combat systems the Navy should be getting and what their specifications are. And I still do a lot of reserve duty
Yeah,
in the Navy. I'm a reserve admiral, and I am thrilled to be in probably one of the most exciting domains in industry now, which is the electrification of the automotive industry.
correct.
And so I've joined EVR Motors, and EVR Motors has designed a new topology for electric motors. Topology is a big word. So a new architecture for electric motors. We've got an improved design of what it looks like. When a motor expert looks at the inside of our motor, first thing he says is, "Oh, that's different. I've never seen something like that." And we say, "That's right. If it looked like everyone else's motor inside, it would be performing like everyone else's motor inside, and we wouldn't have a business."
Wow.
And we've entered a space where, surprisingly enough, there's very little innovation. Electric
Interesting.
motors are electric motors. They've hardly changed in 100 years, 120 years. They went to magnet motors tens of years ago, and they've gone to hairpin coils 10, 20 years ago, some of them,
Yeah.
which have got pluses and minuses. But basically, motors have been very much the same. And we've taken the most popular architecture of electric motors, which is what's called a radial flux motor, and we have changed the way it looks on the inside and the way it's built on the inside. And that lets us make motors that are less than half the size and weight of conventionally designed motors that give out the same power.
That's amazing. Well, we all know that the motors take up a lot of material, and that's very expensive. Wow. Okay. So first of all, how long has EVR Motors been around? When was it first created?
So the company was initially created in 2012 by 3 amazing founders, Eli, Victor, and Ruslan, thereby the name EVR Motors. Although we do have an unofficial version of that, which is Electric Vehicle Revolution.
Either way works.
Yes. And they started out, they wanted to deal in automotive motors from the beginning, but that was a difficult period for that. So they started out doing generators for wind turbines. And just as they got through some nice technological breakthroughs for that, but they decided in 2018, 2019, together with new investors, to do a major turnaround in the company and go from the wind turbines to the automotive market. And that's where the company has been since then.
What year was that? When they
2018, 2019.
Gotcha.
Yeah.
So you've been in that space about 3-4 years.
Exactly.
Now, okay, so what have you guys seen in that? Like, so you came on 2.5 years ago. What have you seen in that space? And like it's a pretty. There are companies that do it. There are not that many, but there are companies that do it. What have you guys learned?
So that space is changing constantly now.
Yeah.
Okay, it's clear to everyone right now that electrification is the future. Okay,
Correct.
it wasn't so clear 3-4 years ago. Okay,
Oh.
it was Elon Musk crazy with Tesla,
Yeah.
a few others talking about it. Now everyone's talking about it,
Correct.
and everyone's doing, and everyone's investing huge amounts. The amount of money that the car manufacturers, the OEMs, are committing to electrification is mind-boggling. That every single one of them, or of almost all of them, are talking about investments of tens of billions of dollars over several years.
Sure.
That's a lot of investment. They're all running towards that, and electric vehicle sales are going up. But it's not just electric vehicle sales or electric car sales. It's everything. It's commercial vehicles, it's trucks, it's two-wheelers, it's three-wheelers, and even the guys who don't go electric in many of the countries will be going hybrid. One of the different versions of hybrid. We'll talk a bit more about that.
Yeah.
Later on.
Yeah.
So there will be relatively few cars sometime in the 2030s that will not have an electric motor inside of an electric traction motor, something that actually moves the vehicle inside it, and that's a huge market that's coming out of nowhere.
Yeah.
And it is ripe for innovation because most of the innovations are going into different places. The innovation is going into the batteries, huge innovation in the batteries, a lot of innovation in the electronics that run the motor, and very little, mostly incremental innovation in the motors. There's a lot of motor design going on. Okay, people are designing specific motors for specific requirements, but that's not innovation, that's design.
Sure.
Innovation to new designs of motors is relatively limited.
Interesting.
So that's where we're working. We've got a very different internal design of the motor.
Now, the motor you guys created, is it, I don't know, is it in production? Can it be used in a vehicle yet? Or is it still in the development stage?
So the first ones that we're working on are smaller motors.
Okay.
They are designed for the 2- and 3-wheeler market segments. So they're small, they're not big enough to go into to run a car.
Right.
But they also work as can also work as hybrid motors.
Mhm.
The first ones we started doing are air-cooled motors, and now we're working on water-cooled versions of these motors. Water-cooled for the same size gives out much more power.
Mhm.
Our basic claim to fame is how small the motors are. Anyone can make a motor, okay? So
Right.
what makes a motor better? It's got to be efficient, and it's got to be small and lightweight. Small and lightweight because vehicle manufacturers are super driven to reduce the size and the weight of everything. Okay,
Right.
the cars are way too heavy as it is. Electric cars are even heavier because the battery weighs too much, and every kilogram you add onto a car reduces the range, increases the cost, and there's no way to cut off a ton from a car by removing a ton. You remove a ton from a car by removing a kilo here and half a kilo there. And so if you come to a major element like the motor, which is one of the heavier elements in the vehicle,
Mhm.
and reduce its weight by tens of percent, that is
Huge.
tremendous.
Yeah.
If you come to a major element that's not just big, but also has constraints on where you place it, like the motor, and you reduce the size by tens of percent, that has a dramatic effect on the design of the vehicle. And this is where we come in.
Yeah.
Our architecture lets us make motors that are much, much smaller and lighter. Now, because they're lighter, why are they lighter? We're using the same materials. There's less material in there. If there's less material in there, they cost a lot less.
Mhm.
And we're doing this without any fancy, expensive processes or materials in there. Okay, there's no carbon fiber, there's no titanium, they're simple, standard materials. magnets, copper for the coils, some steel, some aluminum, standard processes, nothing fancy that costs a lot of money, because there are racing motors that become small at very high cost. In this case, low cost. So we're not only saving them tens of percent in size and weight, we're also reducing the price per kilogram or per kilowatt of power supplied by tens of percent.
Amazing.
So overall, it's a very interesting value proposition, both better and cheaper, that always gets people's attention.
Now, okay, so you have the product. I mean, you created, right now there's smaller engines. What's the plan right now? Are you in talks with companies to actually create a regular size motor for their vehicles? Because I don't see why a company wouldn't want this motor. I mean, obviously it makes complete sense. If you guys are the head of innovation and they're smaller, cheaper, more lightweight, they should be knocking at your door, are they?
Yes, with a but. And the but is that the guys knocking on our door right now are the guys who are interested in the small motors. The guys who are interested in the big motors are saying, quite understandably, when you've got a big motor working, come call us, let's see the results, then we'll talk. And you know what? They're right.
Yeah.
So we're working on the markets that are interested in small motors from a marketing point of view. From a development point of view, we're also developing a large passenger car and commercial van motor. So that one's under development.
Gotcha.
But what's working is the smaller motors. Now, which markets are interesting for that one? Because this is,
let's hear.
Many people don't get this one. The most exciting market in the world right now for two-wheelers is the Indian market.
I was about to say that. Okay.
India has got 20 million plus two-wheelers sold every year. There's a tremendous drive. By the way, just to put that number in context, the number of passenger cars sold per year is a bit less than 100 million.
Gotcha.
Okay, so 20 million is a large number.
Huge.
The Indian government is investing heavily in electrifying the two and three wheeler segments. And they're investing in this both in direct subsidies to the purchase of the vehicles by the consumers and in investment aids and benefits to the companies making them.
Gotcha.
And so the Indian market right now is crazy active. Okay, the phone doesn't stop ringing. Literally, they're calling all the time. And we've already got 2 commercial agreements, 2 leading Indian tier 1s. In the automotive industry, the guy who makes the car is called an OEM, an original equipment manufacturer. That's a car manufacturer, the vehicle manufacturer. And the guys that supply them are tier 1 suppliers. They don't buy just from anyone. They buy from companies that are specialized in manufacturing for the automotive industry, which has got very rigid requirements everywhere in the world, including in India. So we've got agreements with 2 Indian tier 1s who will manufacture our motors. Our business model is built that way. We don't intend to manufacture motors for most of our customers.
Gotcha.
They will never buy millions of motors a year manufactured in Petah Tikva, just outside of Tel Aviv. It's not how that industry works. They'll either make it themselves. Some of the OEMs, many of them, want to make their own motors, and others will buy it from their selected tier 1s whom they are comfortable working with and work with all the time as their suppliers. So our business model is to work with these guys, the tier 1s and the OEMs, depending on what the OEM wants. If he wants to manufacture, wants to farm it out to the tier 1, to design a motor for the specific requirements of the customer after we teach the guys what they can ask for.
Mm-hmm.
Because if a guy, if he wants a normal motor, and when a vehicle designer specifies his vehicle, he says, okay, I need to go this speed with this much weight, this much wind resistance. This is the power of the motor I need, and therefore it has to be X, Y size. And if he specifies that, he's not getting much of an advantage. We come up to him and say, with the size you wanted, we can give you much more power. Or with the power you wanted, we can give you a much smaller motor.
Mm-hmm.
So once we educate the OEMs and discuss with them what they want and what they can get, We then design a motor for them for their specific requirements
Interesting.
and help them transition to manufacturing, and they manufacture the motors for themselves or for their OEM customers. And we get royalties. And because the motor is lower cost, there's plenty of happiness to go around between us and between our customers in the excess profits from the reduced price of the motor.
That is
So
very interesting.
we're already teamed with 2 large, significant Indian tier 1, and with some and working with quite a few OEMs, including the largest two-wheeler manufacturers in the world, with whom we are working. Some of them are, as we speak, evaluating motors. Others are preparing to. Others are looking at it. And
The largest one is Honda.
no, the largest two-wheeler manufacturer in the world is an Indian company called Hero.
Oh, interesting.
The second largest is an Indian company called Bajaj.
They got the market.
They've got the market, but they've got other companies. Bajaj, for example, one of their daughter companies is KTM. It's an Austrian off-road two-wheeler, off-road motorbike manufacturer, which is probably the world's leading off-road bike manufacturer. That's an Austrian company, but owned by Bajaj. So these companies are huge. And Honda and Yamaha and a few others come in after them.
Gotcha.
Still big, still huge, you know, great customers to have. And I can't say who we're working with and who we're talking with, of course. But the biggest two-wheeler manufacturers in the world are Indian.
Interesting. Now, are they? So they have. So you're creating the design for them, and they're gonna start manufacturing it. Have they started manufacturing it yet? You're still in the process of the learning process with them.
We're currently manufacturing initial amounts of motors that will go out for evaluations and for testing and for demonstration.
Amazing. So this is happening at the moment. This is really happening.
This is
EVR
really
Motors,
happening.
they'll be on the road quite soon.
There are test motors out on the road already.
Amazing.
And we should have motors in the world out on the road commercially, hopefully next year. The Indian market is a fast market; it moves very fast.
Yeah.
So hopefully by next year we'll have motors actually, commercial customers riding our motors and hopefully coming home happy.
Very exciting.
Moving very nicely, very, very nicely. The second market that we're working on now for these small motors is a totally different market, and that is hybrid vehicles.
Nice.
So let's talk about those for a moment. Especially in the States, they're not very popular, but presume that sometime in the 2030s, one can argue about when 50% of the cars are going to be fully electric.
Correct.
50% of the cars, the other 50%, are going to be combustion engine. The main drive for electrification is regulatory. It's the different countries, especially in Europe and some other countries, not enough in the US or in all the states in the US, putting regulatory pressure on the vehicle manufacturers to reduce emissions. And that requirement is, especially in Europe, an across-the-board requirement. They look at the emissions of all the cars the OEM has sold that year, and everyone is certified for certain emissions, and they encourage them to reduce those steeply.
Yeah.
Behind the word encourage are steep carbon emission fines.
Correct.
So if you're emitting too much, you're paying high fines. So the vehicle manufacturers have high motivation to reduce their emissions. And the main way to do that, it used to be diesel, but diesel after Dieselgate is in the wind.
Yeah.
For a variety of very good reasons. So the way to do that without going full electric, for those customers who don't want to go full electric at this stage because of charging, because et cetera, is to go hybrid. And there are 3 basic kinds of hybrid out there. There's plug-in hybrid, which is a big electric motor together with a big combustion engine. That's a powerful, expensive combination. I don't know how long it's going to last. There's normal hybrids. They're doing several tens of kilowatts of power, usually high voltage. The Japanese and the Koreans have been leading this pack. The Japanese are still there. Koreans are starting to move out and into full electrification. But there's a new type out there called a mild hybrid. A mild hybrid says the philosophy has got two parts to it. One is 48 volts, very low voltage. And very low voltage means the safety requirements in the electrical system are much lower and therefore much cheaper to make. The second part of it is, let's put it as an add-on to the motor with as little ramifications to the combustion engine as possible. The easiest way to do that is replace the alternator. It's called a belt starter generator. There are other ways to do it in different hybrid configurations. I won't go into all the technicalities, but basically they say, let's put as small and cheap an electric motor as we can into whatever space we've got already in the vehicle, integrate it as simply as possible, and help the combustion engine in three things. One, let's generate more power for the other vehicle systems. Cars nowadays have so much electronics for the radars and the lane keeping and the cameras and all the other stuff, and more air conditioning and all your power seats, et cetera, et cetera, et cetera. They need electricity, and these 12-volt alternators are at the edge. They can't meet all the requirements. So let's give more electricity to all these systems. Then comes the interesting stuff. They want to do this start-stop stuff, which starts and stops every time. It's a really annoying system. I hate it. But it's good for emissions. So, and this takes a lot of power. So let's do the start-stop stuff better. But most importantly, let's help the combustion engine in its weakest point, and that's with accelerations. So let's boost the acceleration of the combustion engine, which is where the combustion engine is the most wasteful and creates the most carbon emissions, because it doesn't have much torque at low speed, with where the electric motor is best. Low speeds, high torque boost. Let's boost the combustion engine with the electric motor. And so they want, in a very small space, to get a lot of torque and power for short periods of time. And in some cases, we can give them, and in fact, in all cases, we can give them a lot more torque and a lot more power for a longer period of time than they can with normal technology in the same size constraints they've got.
Gotcha.
And even drive the vehicle at low speeds. For example, you're now crawling along in traffic jam in the start-stop traffic. You don't have to start and stop the motor, the ICE engine all the time. The electric motor will do it. You're not driving fast. You don't need a lot of power. You don't need very fast acceleration. The electric motor will do it for you and save a lot of emissions. If it saves a lot of emission, it more than pays for itself in reducing the carbon fines the OEM has to pay, which is what's interesting for the OEM.
Yeah.
Not
Wow.
So we're in discussion with quite a few potential customers on what we can do for them with our technology, and for a very reasonable price, in fact, reduce the price and increase the performance and get them more carbon fine savings and keep simple integration. So this is some of the exciting stuff we've been doing over the last few months, and we'll be demonstrating these with several potential customers over the coming months.
That is very, very cool. You guys are getting it everywhere, I see, because everyone needs a smaller motor and everyone wants one that costs less. I mean, why? That makes complete sense.
It makes complete sense. It's got two problems to it. One is this industry is a very, very conservative industry.
Yeah. And
it moves slowly, which is why we're working with the manufacturers and not directly with the OEMs. The second thing is, when we're a small startup, okay? So we're a small startup talking to these huge conglomerates. Who do you talk to in the huge conglomerate? You talk to their innovation guys, okay? Or sometimes to the management. What do they do? What do they understand about motors?
No.
as much as the next guy down the road, not enough. So who do they go to? They go to their motor guys. And they come to their motor guys and say, hey, you know, you've got 17,000 PhDs working on your motors over there. There's this little company from Petah Tikva
Yeah.
who've got 4 PhDs and 30 people, and they say they can do a motor that's half the size of what you could do. Oh yeah, the guy says, I really want to hug these guys. I love them. Yeah, bring them on. So there's a significant NIH, not invented here, faction that you have to get around, and it's part of the challenging and fun part of the business.
Yeah.
But in the end, the results are measured on a test bench, and size is size, weight is weight, and performance is performance. And so we're going in nicely to the two-wheeler world because we've got the performance and the size. We're now working on getting into this mild hybrid world. And from there, we'll move on into the passenger cars. And we'll start next year when we have a passenger car motor running on the test bench and showing performance, with which we can come to the guys and say, here's the motor. Look how small it is. This is the power measurements. Now tell us if it's interesting or not. It probably will be, very. Yeah. But the business is in small motors just as much as in the big ones.
Correct. It's so interesting that, like you said, like having these humongous companies, I'm looking at this teeny company, and you guys are like, listen, our motor is just smaller. So that, like, it's smaller, it's easier, it's better to use, and it's probably hard for them to believe. But that's so crazy. Now, can you tell me about the company a little bit? So it's in Petah Tikva. How many employees are there at the moment?
We're about a bit over 30 people, most of them in Israel, a few of them abroad. 4 of them PhDs.
Yeah.
All of them with significant industry experience in big industry, or many of them with experience in big industry. It's not a youngster's startup. The average age is relatively high because it's an area where you really need a lot of physics and a lot of mechanics and a lot of electrical engineering. Gotcha. So we've got very experienced people there. And they are fantastic. They're it's very
sometimes
exciting.
A smaller team sometimes works better. You can just bounce off ideas and just create stuff, which is what you guys are doing.
We're doing it all the time. We just got 9 patents approved, and some of them are already granted in less than a year.
That's amazing.
We've got quite a few more in the pipeline, and they'll probably be approved by next year. And we'll have quite a few more the year after that. We're constantly innovating, improving our design, changing the way we think, solving problems, getting great ideas. It's very exciting.
Now, coming from the other, you've been in a lot of different, I'm not gonna say industries, because you worked in the Navy and also in the space industry. I guess I don't know how to explain it, the Space Force.
Industry. I worked in defense industry and in space industry, so aerospace, yeah.
And so just tell me about, like, coming from those industries to this industry. What I mean, they're all different, but like, did you learn something from like the Navy that is helping you in this industry? Like, I don't know, like, how do you combine all those amazing fields?
I learn all the time. I love learning.
Yeah.
And it's part of the fun is going from one industry to the other and taking a lot of understanding from wherever you go. But for example, Israel's space industry, our claim to fame, is making satellites that are way smaller than normal satellites and perform much better. And we've got by far the world's smallest satellites. There are a lot of good reasons why we need to do it like that in the Israeli space industry. And we've got satellites when the normal satellite guys look at them and say, you can't do what you say you're doing with that size of satellite. And then they see the pictures and say,
it works.
You can. You know, how do you do that? So there seems to be a recurring theme here. There are big differences. The aerospace industry is not price sensitive. And the automotive industry is very price sensitive.
Very price sensitive.
And some of our engineers come from aerospace, and it takes a bit of a beating, to remind them that exotic materials are out and it's got to be cost effective. But there's a lot of similarity. They're all big organizations.
Yeah.
So I have personally a good advantage in coming to the startup industry, the startup world, from a big corporation and I know and understand how corporations work. And in most cases, the startup guys have never themselves been in a big corporation. They don't understand how the organizations work and what limits, and they sort of, they look in and keep saying, but they don't get it. Okay, they don't get the culture. And I've come from that type of culture, and so when we're working with them, it makes life a bit easier.
Got you. Okay, so EVR Motors has been in production of motors for about 3 years, and we're going into the Indian market soon. Next year, hopefully, you'll have a prototype to introduce into smaller vehicles. I mean, into actual vehicles, regular vehicles. What
cars, passenger cars.
It's the regular cars. Now, so let's look down the road. Let's say the future of EVR Motors, right? 5-10 years down the road. What do you see it? What do you see it being? What do you see it being? Anything.
I see a company that is designing tens of motors per year for a wide variety of customers all around the globe, with millions and millions of vehicles every year coming out of all sizes, coming out using our motors. I see us expanding into more and more areas, all of the mobility market. So trucks, buses, aviation, very interesting area for us, et cetera, et cetera. And I see our technology becoming the gold standard for electric motors. If we're as good as I think we are, people will have to either join us, whether it's directly or they'll find ways to do something that's similar, or slowly become irrelevant.
Right.
Because if we are tens of percent smaller, lighter, and cheaper, then and you know, these guys need to keep. They work very hard to keep a competitive edge.
Yeah.
They'll have to come around. So I think we're going to be taking large parts of the market. There may be new topologies that come out that are very different, and the market may go that way. I mean, we don't have the only say on innovation. Yeah. There are a lot of other people trying to innovate. Right. But in the main bulk of motors, which is what's called radial flux motors, we're pretty unique. There's very little significant innovation in the topology of those types of motors, and about 85% of vehicle motors are radial flux. So I think we're in a pretty good point, and if we're as good as we think we are, we'll be in a very, very good point in a few years.
I agree. I am very excited to see the future of EVR Motors. I mean, there really doesn't seem like is an alternative for most companies that want to sell. They need it, and you guys have the product, and you guys will be introducing, you know, the passenger one soon. Which I think once one company takes it, the other ones are going to have to look at it. So it's very exciting, and yeah, I think we're gonna hear a lot about you guys. I think we're gonna hear a lot about EVR Motors down the road.
I hope so. I hope so.
And yeah,
I've bet my career on it. So
listen, we're gonna watch. I'm gonna personally watch you, and we're gonna watch how you guys grow and expand, and look out for the news to see, you know, collaborations between you and other companies. And yeah, it's a very exciting world out there, especially for electric motors. So yeah, can't wait to see.
Perfect. Thanks a lot. It's been a great talk.
Thank you so much. It's been amazing.
Thanks, all. Bye-bye.